Good morning, pilot teachers and students, and good morning, class.
Good morning, Mr.
Thank you, Ms. Shida. All right. In our last two lessons, we went through elastic potential energy, and then I gave you some work to do, and those work was given to you as a homework. All right, we'll just go through and then study each one of these quickly. All right, one of the graph that was given, you only had this, but probably the line will have to run from 0 right up to 2. Okay, so in here, if you want to find the work that is done, the work done is the area under this graph. Okay, remember in our last lessons on measurement, when we were looking at the graphs, you found out that the constant is always the slope of the graph. Now there is an equation also given to you, and that is the work done by this elastic potential energy, and that is half kx squared. The constant can be found from the graph. You can work out the constant here and then substitute that into the equation. Work equals to half kx squared to give you the energy that was being used, or let's say the work that was done. The answers will be 0.4 and 0.1. Okay, that is question number 1. If you write for number 2, you also had something like, but this time you only have this shown, right? If you can draw that nicely, place a straight line that is running from 5 right up to 4, and then it touches this. Okay, quickly, if you don't have this line, I want you to draw that line quickly, and then I will explain to you the questions. The questions remain the same, but you can always come up with the answers. I will give you the answers to verify or check against those questions. All right, so the line should run from 5 to 0.4. If you want to find the area under the graph, that is simply, all right, this area, that is, and not this. So only this area will be used to calculate the work that is done. All right, as I've said, it is also similar to the first question. You can also find the constant, and that is the slope of the graph. Okay, that constant is simply the k, or from that equation, half kx squared. All right, here the answers you can check. Write the answers down, and then you can check against those graphs that you have just corrected. All right, I'm sure for the first one, most of you should have got that right. That is 0.4, and then 0.1 joule. For second question, that is 2a and 2b, you have 3.0 joule, and also 3.0 for 2b. All right, quickly write the answer down. I will move on to our topic that we will study, and that is on inclined plane. All right, mostly if you are dealing with any inclined plane, there are two types of inclined plane. One of these inclined plane will be a smooth, and you have another one which will be sometimes rough. But we can still consider friction in these two cases. We can still consider friction exists in whether it is smooth inclined plane or in a rough inclined plane. Friction still exists. Now, if you were to consider, let's say, a smooth one, then probably in our own perspective or in our own thinking, we can say that there is no friction because it is quite smooth. So for this case, let's say if an object is sliding down or if it is sliding up an inclined plane, you know, an inclined plane will have to look something like this. Okay, let's say if a crate, or let's say a box was placed here, and then if it is going to slide down this, and if it is smooth, we will not consider a frictional force. Okay, we will only consider the angle in which it is moving. Now, last time in our last lesson, I did explain to you how the work will be done, especially when you are pulling something at an angle. This time, you are not pulling it, it is sliding down. So if you want to find out the work that is done, then work equals to F first sine theta. That is the angle in which that object is sliding down. Right, there are two most important points about inclined plane. I will now ask you to just quickly copy the notes, and after that there will be one or two questions given to you in relation to the topic. Okay, that is the same principle that we'll be using. The loss of this potential energy will be equal to the kinetic energy. So you have mgh, which is when you, because of the height, equals to half mv squared, and that will be calculated, though, let's say the amount of work done will be calculated using the force times distance times the sine of that angle in which it is sliding down. Okay, since we have this, which is the same as, okay, you have, in other words, when there is a loss in this, it will be the gain in that. So mgh, which should be equal to half mv square. And then because of all of this, we will have that as mg as s is the distance, this one, okay, that is the distance. Because it is smooth, we cannot consider the frictional force, so it is just a distance mg as sine of that angle. Okay, that is the work that is done. All right, there are two important points that we can know. In this case, if that is a smooth inclined plane, the frictional force, or it can be either the air resistance, is not considered. However, you have to figure this out. In reality, we still have some frictional force or force existing, whether it is a smooth inclined plane. And here is point number 2. The velocity vector is not vertical. This time it is parallel to the plane. Okay, I'd like you to copy that activity quickly. There are 2 activities. This is the first activity question, and after you finish copying that, the first one, I'll give you the next, or you'll be given the next to copy. And also you'll be given some time to complete that activity question. Pilot students, I would also want you to quickly go through, and or you may copy this the activity question. Your teacher will help you to solve this question, or you can try that, but if you need any help, you can also ask for help. So quickly do that now. That is correct. Correct. Okay. Hands up if you have finished question number 1. All right, finish copying. I will give you question 2. This is question number 2. Let me choose. Okay. You show that correction number 1. Huh? No, that's okay. Correction number 1. Yep. Okay, you go for question number 2. Complete. Use the same, not same as this, because in this one, if you tie a rope and then pull it on the ground, you are applying to pull this way, then that actually object is moving along the, and then use course, yeah, use course. But this time it is sliding, yeah, up an inclined plane, yeah, that's right. So you decide to use this one if frictional force is ignored. Okay, you see the difference when you come to rough inclined plane in the next.
We're still gonna use the same.
Yeah, the same. Yep, okay. Yes. Yes, okay. Okay. Most of you have finished the activity questions, and I will now ask Samuel to do your correction. That is for the first question. And then question number 2 will be you will do question 2. Okay, Michael will do question number 2. So you can come up now. Just go through, write your answers, and then give you explanation of how you arrive with the answer.
Using the formula, work is equal to force times distance times sine theta. The weight, the mass of the object is given as 50, so use another formula, force equals mass times acceleration, to get its force. So you can use in this formula. So you multiply 50 by 10, you get 500 times the distance, 10 meters, times sine 30, which if you punch on your calculator, you get 0.5. And you end up with the answer 2,500 joules.
2,500 joules. Raise your hands if you have 2,500. Okay. That is correct. Pilot students, if you have 2,500, that is the answer to question number 1. All right. Move on to question 2. Michael, just clean this one and then.
Using the formula, force by distance by sine theta will give you work. Substitute numbers in. Mass is equal, the mass is 50 kilograms. G is acceleration due to gravity, and s is the distance. So you substitute that in 50 by 10 by 4, that will give you 2000. Sine 40 is equal to 0.64, that's rounded to the nearest two numbers, and multiply that and your answer will be 1285.58 joules.
Okay, the answer here will be 1285.58 joule. So, pilot students, if you have this answer, that is correct. Okay, 1285.58 joule. All right, quickly to recap on what we covered in the lesson. In an inclined plane, especially, there are two types. One is a smooth inclined plane and then a rough inclined plane. But in reality, we seem to say that a smooth one does not have any friction. But we seem to have friction force existing in both the smooth inclined plane and the rough inclined plane. Now, if we want to consider this rough inclined plane, there are two important points of facts that you should know. And one is that air resistance and frictional force is ignored, right? And secondly, you'll find that the velocity will be always parallel to the plane. It is also moving in line with the plane. So those are the two most important points that you should know, especially on an inclined plane, which is quite smooth. All right, so that brings us to the end of the lesson, and in our next lesson, we will study the topic on a rough inclined plane. Okay, you may stand up. Our key phrase is a smooth inclined plane. Good morning, pilot teachers and students, and good morning, class.
Good morning, Mr. Sarima.
Thank you. Please sit down.